Hey you! Do you want to know what kind of physics goes into throwing a ball?
No!
Well, you're in luck. Hi, I'm Mr. Kyle, and this is Mr. Jackson. You can tell we're physics teachers by the way we're dressed.
Now to begin your physics journey with projectile motions.
What's projectile motion?
Projectile motion is the motion of an object thrown or projected into the air, subjected only by the acceleration of gravity.
Oh, so it's how far the ball will go after I throw it? So how would I solve for projectile motion?
Well, before we jump into any solving, we must understand a couple things.
1. The Earth's gravity has the acceleration of 9.8 meters per second squared.
2. The equation to find velocity is distance divided by time.
And finally, the equation to find a distance from a projectile is sine 2 theta v squared divided by g.
Wow, that was a lot of information, but I think I'm starting to get it.
Wow, that was great. Now give that ball a throw.
Awesome throw. Now, you see when you threw the ball, it went in an arched path. This arched path is called a parabola. And it goes in an arched path because of the Earth's acceleration, which is gravity.
Oh, I get it. So the Earth's gravity is pulling it back down to Earth?
Precisely. Now, when you threw that ball, you threw it at an angle of 45 degrees, which is the maximum angle of launch. This will substitute for theta.
Also, you threw the ball a total of 15 meters. This will substitute for our distance.
The ball also took 7.4 seconds to go from launch to landing, which we will be substituting for time.
So now we're going to solve for velocity. So, velocity equals the distance divided by time. Our distance of 15 meters divided by our time of 7.4 seconds will give us a grand total of 2.03 meters per second. Now let's solve for projectile motion. So, with our givens, we insert them. 2 with the 45 of theta. The v squared would be the 2.03 squared divided by 9.8, which after you plug that into your calculator, you will get a grand total of 0.420 meters per second. I'm not kidding, 0.420 meters per second.
Wow, that's crazy. Who knew you could get so much information from throwing a ball? But now would the projectile motion be any different if I threw something like this?
Yes, because the rock weighed approximately 1.5 pounds, while the basketball weighed about 20 ounces.
Yes, and the heavier the object being thrown, the more force is going to be applied.
So if I wanted to throw this at the same distance, I would have to use a lot more force? So random question, how would the projectile motion be any different if I was on the moon?
Why would you be on the moon?
Now, if you're on the moon, the gravity would be much different. See, the gravity on the moon is 1.6 meters per second squared. And as you can see, that is a significant drop compared to Earth's gravity, which is 9.8 meters per second squared.
But wait, I thought there was no gravity on the moon.
No, there is, just not a lot. If there was no gravity, however, instead of the object's path being a parabola, it would just be a straight line.
So if you were on the moon, the strange gravity will not at all affect the direction of the object you were throwing.
Also, I've noticed the object is getting a lot more height on the moon. Is that height affecting anything?
Well, you see, the height affects the trajectory of the projectile.
And the horizontal displacement increases as the height increases.
What is horizontal displacement?
Horizontal displacement is the displacement in the horizontal direction.
Or in terms that your brain can comprehend, it's the range.
Wow, thank you Mr. Kyle and Mr. Jackson for teaching me everything I need to know about projectile motion.
Of course.
And if you have any other questions about physics, you can always ask our physics mentor, Robert Mallison. You can contact him at rmallison@student.boyertownasd.org. Where's your glasses?
Oh, I'm...
God!
I couldn't see. I was giving...
I'm in cooking class right now. The basketball only weighed roughly 20 ounces. Did you not know what you were saying?
No.
Now, let's solve project
Wait, any understanding?
No, before we jump into any solving,
Okay. We have to.
understand a couple topics.
Gotcha. What is it? Hi.
Hey now.